All right, good morning, guys. We are looking at our next unit, still dealing with logic. We are looking at some of our old postulates today that we worked with last time, and now we're going to be adding some from algebra that we use a lot in geometry. So we're going to be looking at how we can use these different postulates and theorems to start writing what's called a proof. So before we jump into writing proofs, let's just review some of these postulates for a second. So this first set that we have here are the same postulates that were in my last video that deal with points and how many points you need to make a line, how many points you need to make a plane, how many points are contained in lines, and so on and so forth. So those are all the same postulates that we've already seen. They just have a little more detail with them now in some pictures. Now, one that we want to look at this morning that we didn't look at last time is this last one down here that says if M is a midpoint of segment AB, then segment AM is congruent to segment MB. So this goes back to making our segment addition for part 1 is congruent to part 2, and that's exactly what we've got going on here. Your part 1, which is A to M, part 2, M to B, and again, this is called, and these are congruent by that piece that we have there. And now basically what this specific postulate is called is more of a definition. This is our definition of a midpoint. All right, these are our definitions of midpoints. This was one that was not talked about in the last video, while all the other ones were. Remember, we had 2-1, 2-2, 2-3, where all those other postulates came into play. So now let's take a look at some of the algebra postulates that we can also use with our points, lines, and planes. And you have actually seen all of these when you were working in Algebra 1 when you solved an equation. So the addition property of equality, or just addition property for short, is the property that says you can add something to both sides. And so that's what we're looking for this property. So if we are working through these postulates for these properties of equality, again, we start with the hypothesis and what was done to that hypothesis to get to the conclusion, which was, again, we added that C to both sides. So we're adding the same thing to both sides there. All right, same idea for the next one, which is our subtraction property, which says we can subtract to both sides. Which is what we're doing here. So both sides of the equal sign has the exact same subtraction happening. And then we have the same thing for multiplication and division. I can multiply to both sides. And that's what's being done here to the A and the B. Both of them have a multiplication of C with them. So you've multiplied both sides by C. And then the same thing for division. We can divide to both sides. So both that same A and B have been divided by the same value. So those are all the ones that we use. Those are the 4 that we use whenever we solve out equations. Now there's a few others that we're going to look at here in just a second. But now we have the reflexive property. This one is used more when we deal with our geometric proofs. So if you notice, from beginning to end, there is no change in our whole property here. So A is equal to A, they stay exactly the same. The sides are exactly the same. Moving right along, then we have what's called your symmetric property. So again, if we focus on the hypothesis and what was done to it to get to the conclusion, all we did for this one was notice what happened to those two letters. The only thing that they did was switch places. Just like if I said x is equal to 5, symmetric says, oh, I can switch that and say 5 is equal to x. They just switch or change the order. Our next one down is your transitive property. All right, so again, let's compare what's being done here from the hypothesis to get to the conclusion. All right, so notice from hypothesis to conclusion, there's now some stuff missing. All right, our A and B parts that were in our hypothesis are now gone, and we're jumping straight from A to C because we can eliminate extra information. Or we can eliminate repeat. So if B is repeated for both of those pieces, then I don't need it. Because if A is equal to B and B is the same thing as C, then my beginning and my end have to then also be the same. So we can eliminate anything that's being repeated in our problems, and we're just left with A and C. All right, next we have the substitution property of equality. So substitution property encompasses a couple of different ideas here. All right, so we've got if A is equal to B, then A can be replaced. That's one of our big things here. A may be replaced or substituted in. Some of the other ones that you can think about when we're looking at this is combining like terms. Okay, that is another kind of substitution that we do when we solve. And there's other kinds of things that we can get to if we simplify equations, simplify out parts. Those are also ways of using your substitution property. Okay, so there's lots of different ways, lots of different things that actually come along with substitution. All right, so moving right along, another big one that you use in Algebra 1 is the distributive property. All right, it behaves kind of like multiplication, but your distributive property says whatever is outside of these parentheses is multiplied to both pieces inside. So it's a kind of like multiplication property. But if you notice, we're not multiplying the same thing on both sides of this equation. All right, but again, this is distributing. Now, the other big one that we use a lot in geometry as opposed to Algebra 1 is what we call our definition of congruence. All right, definition of congruence is specifically talking about things that are the same size, same shape, same measure, like it says there in our notes. We start off with, we've got two parts here. We've got the hypothesis of the beginning one that started off with congruent, and then we moved to our next piece, which took that congruent symbol and then said that you have an equal. So congruence says that two things are congruent, then their lengths have to be equal. Okay, and this could go the other direction because look what's going on in the next line. If my angles A and B are congruent, same thing for angles here, then their measures have to be exactly the same. And again, this can go the other direction, like I was just saying. If I know that the length of AB is equal to the length of YZ, or the measure of A is equal to the measure of B, then I can reverse that and then say the two are congruent. So what we're looking for with your hypothesis in the conclusion is, are the values, the letters in this case, staying the same to represent the segments and the angles? And are we just changing from congruent to equal or equal to congruent? So those are kind of our things to watch for. So let's use these different properties and see how we can go about writing out one of our first proofs here. And for this one, we're going to use an algebraic proof. So before I look at that, notice we've got a table here, and before I look at one of my columns, I want to take just this algebraic steps column here, and we're going to solve out this equation. All right, so like the instructions say, we're going to solve 6x plus 2 times the quantity x minus 1 is equal to 30. So we're going to use these different rows in this table here, and we're going to solve this out. And then we'll go back and see how your different properties are being used. All right, so for our first one, I have 6x plus 2 times x minus 1. So distributive property is going to have to be first, because we have to simplify parentheses before I can start doing anything else. So I still have 6x plus, now we distribute 2 times x, 2 times negative 1 is equal to 30. And let's keep going. Now we can combine our like terms. So 6x and 2x is 8x minus 2 equal to 30. Notice I'm putting each level of my equation in a different row. All right, so if I continue to solve this out, my next step would be to add 2 to both sides of this equation. All right, my 8x is still there. My minus 2 and plus 2 cancel out, and 30 plus 2, I'm going to replace that with my 32. Let's keep going. My next step would be to divide both sides by my 8. My 8 over 8 would cancel out, and my x is going to be 32 divided by 8. I'm going to replace that with the 4. And there's my final result. So let's use this now and go back to our column, and let's state with what we have here. Now, anytime we do any kind of proof in geometry, this specific outline that we're using here is called a 2-column proof, because we've got essentially 2 columns. One that has the different steps we're taking to get to the result, and the other column is for the reasons why. So the reasoning or the justification behind each step that I did. So we always start off with your given problem. So the equation that I was given to work out, that is the given problem. Now, a lot of times we just simplify this idea and just write given, because this equation was given to me to solve. So let's keep going from there. Now, as we work through this proof, we have to see what did we do from row 1 to row 2. So from my first row to my second row, what did I do to get that line? Well, that was our distributive property. So we distributed. Okay, once I had 6x plus 2x minus 2 equals 30, what did I do from that line to get to the next one? Well, we had 6x plus 2x, and I even said we are combining like terms. Well, for our properties, we talked about combine like terms falls under the substitution. Because again, I am substituting or replacing 6x plus 2x to get 8x. So again, combining like terms falls under the substitution umbrella here. All right, so let's keep going. So from now 8x minus 2 equals 30, my next step was that I added 2 to both sides. So this is an addition property. All right, and then keep going down. All right, I still had my 8x because my minus 2 and plus 2 canceled out. 30 plus 2 gave me 32. So again, I am replacing or combining that part, 30 plus 2 for 32. So again, that falls under substitution. All right, so 8x equals 32. And then my next step, I divided both sides of my equation by 8. So that was my division property. And then my last and final step, I took my 32 divided by 8 and replaced it with 4. And again, that falls under substitution. Okay, so again, that's how we work out and use these different properties to solve out your equations. If I didn't have the addition property, then I could not add that 2 to both sides. If I didn't have the division property, I couldn't divide both sides of my equation by 8. If I didn't have substitution and the combining of like terms, I could not get 8x from 6x and 2x. Okay, so all of these properties, even though you might not have known their actual names, now we can see how Algebra 1 helps us in geometry with these proofs. All right, so now let's try some matching here. So for these last questions we have here on the notes, we are going to state the property that justifies each statement. So again, what we want to look at is the hypothesis and the conclusion. What happened to get from one to the other? Well, in this case, measure of angle 1 equals a measure of angle 2. Notice the conclusion, measure of angle 2 equals a measure of angle 1. The only thing that happened was a switch. So if the only thing that happens was a switch, this is symmetric. All right, let's check out the next one. So we'd start with your hypothesis. If the measure of angle 1 is 90 and the measure of angle 2 is the same as the measure of angle 1, the only thing I have left in my conclusion is that the measure of angle 2 must be equal to 90. So we've eliminated or removed parts of this piece. Notice with both of these, angle 1 is repeated. So we removed repeated information. If I remove repeated information, that was transitive. Okay, let's keep going here. All right, if the length of AB equals the length of RS, so there's our hypothesis, then the length of AB equals the length of WY. Notice again, all we did was remove repeated information. So this is another symmetric, but this time done with segments instead of angles. So again, this was, I'm sorry, not a switch. This was remove the repeats. And so was the one before it. We removed the repeats. Okay, let's check out number 4. All right, if the length of AB equals the length of CD, then 1/2 of AB is equal to 1/2 CD. All right, notice this time, from beginning to end, hypothesis to conclusion, the only thing that's changed is both of them are multiplied by a 1/2. So this is our multiplication property. All right, let's look at our next one. So if the measure of angle 1 plus the measure of angle 2 is 110, and the measure of angle 2 is equal to the measure of angle 3, then the measure of angle 1 plus the measure of angle 3 is 110. All right, so let's compare here. What happened from beginning to end? All right, so notice that angle 2 is the same as angle 3. Angle 2 was removed, and angle 3 was put in. This is your substitution. We replaced. We replaced angle 2 with the angle 3, and we substituted it in for our problem. All right, let's look at the next one. The length of RS is equal to the length of RS. Well, guess what? There was no change. Which means this is reflexive. All right, 2 to go. All right, if the length of AB equals the length of RS, and the length of TU equals the length of WY, so then what did we do here to get to this one? All right, so we start off with AB equals RS, and TU equals WY. So if TU and WY are exactly the same value, then we have technically added to both sides, added the same thing to both sides. So this is your addition property. All right, and then our last one. If the measure of angle 2 is equal to the measure of angle 3, and the measure of angle, if the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 2 is equal to the measure of angle 3, then notice the only thing now that we're left with is what measure of angle 1 and the measure of angle 2. So we have removed the repeats. So this goes back to your transitive. All right, so I hope you guys enjoyed learning a little bit about how we write proofs in geometry and how you can use your different properties to solve out the kinds of problems that we're going to be looking at. And again, compare your hypothesis to conclusion to see what happened with your properties and know which one we need to use. So guys, please don't hesitate to reach out to me if you have any questions at all. And I hope you have a great rest of your day. Bye, guys.